Assalamualaikum and hi everyone. Today my friends and I want to discuss about the first virtual lab for subject DJJ 30093 Engineering Mechanic. The title is Hooke's Law. First, I will introduce my group members. Muhammad Faizal bin Muhammad Sanib, metric number 08DMP20F1006. Second, Lydia binti Junis, 08DMP20F1007. The third one is me, Siti Zulaika, metric number 08DMP20F1008. Next, Nur Hazira binti Habib, metric number 08DMP20F1011. And the last one is Duratul Aini binti Abdul Aziz, metric number 08DMP20F1012. The outcome from this visual lab is understand the basic Hooke's law and find the spring constant Hooke's law. The theory: if an applied force varies linearly with position, the force can be defined as F equals to Kx, where is called the force constant. One such physical system where this force exists is with a common helical spring acting on a body. If the spring is stretched or compressed a small distance from its equilibrium position, the spring will exert a force on the body given by Hooke's law, namely F equals negative Kx. Where F is known as the spring force, here the constant of proportionality K is known as the spring constant, and X is the displacement of the body from its equilibrium position at X equals to 0. The spring constant is an indication of the spring's stiffness. A large value for K indicates that the spring is stiff. A low value K4 means the spring is soft. Generally speaking, springs with large K values can balance large force than springs with low K values. The negative signs in equation 1 indicates that the direction of F is always opposite the direction of the displacement. This implies that the spring force is a restoring force. In other words, the spring force always acting to restore or return the body to the equilibrium position, regardless of the direction of the displacement. An applied force acting on our Hookean object will cause it to be displaced, stretched or squeezed by some amount, X, the ratio of the change in allied force and the change in the resulting displacement is called the spring constant and can be written as follows: K equals to allied force divided to resulting displacement.
To show the tutorial on how this virtual lab works, first copy this link and paste in Google. Click download. Wait for a while and open the file. Select intro and select the compressed spring constant yang the first one and adjust spring constant 1 to small and adjust large for spring constant 2. Take natural lag and equilibrium position. Take any force and hanging at the spring constant 1 and drag the ruler to measure the elongation and repeat for another force. After that, repeat for spring constant 2. Okay, thank you.
Saya Lydia Junis dari kelas B2E. Saya akan menerangkan belajar yang pertama yaitu spring yang pertama. Mula-mula dengan hari nilai X, tapi nilai X yang diberi dan unit X dalam unit M, so kita kena convertkan ke dalam M. Kita kena tukarkan nilai gram itu kepada kilogram untuk dapatkan nilai mass. So dalam result itu pertama kita akan cari force. Formula bagi force adalah F sama dengan Ma, force sama dengan mass dengan acceleration. Lepas kita dah dapat nilai force tu, kita kena cari pula nilai K, iaitu spring constant. Bila untuk cari nilai K adalah F sama dengan Kx. Lepas tu kita cari nilai tersebut, kita cari nilai coverage pula. Kita kena pakai guna formula K1 sama dengan K2 K3 slash 3. Sekian dari saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Hazira binti Habib from the MP2E. Metric number 080 MP20F1011. Today I will discuss the result related to the second spring, so let's look together. At first, we set the greatest spring thickness, turn on natural length, equilibrium, position, and move able line. We take a 50 gram weight, put it on the spring, and take a ruler to measure the X rating, and we get 5 cm. Next, take 100 gram and take a reading equal to 9 cm. And finally, 250 gram, a reading of 23 cm, and we fill in the table. After we enter the data into the table provided, we must first convert the value of G to kg and cm to meters. After that, we find the value of force. The force formula is F equal to ma. After we find the force, we also find the value of the spring constant. The formula for K, F equal to Ks. After that, we find the value of K average, K1 plus K2 plus K3 part 3. So the value of K average for spring 2 is 10.45.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizal bin Muhammad Sanad from class DMP2A. Today I want to explain about graph force versus elongation. First, you must know the coordinate of graph force versus elongation. For the spring constant one, elongation is 0.1 and the force is 0.49. Second plot is 0.2 elongation and the force is 0.98. The third plot is 0.5 elongation and 2.4 force, and value of K average is 4.905 for spring constant 1. For the spring constant 2, 0.05 elongation and force 0.49. Second plot is 0.09 elongation and force 0.98. For the third coordinate, 0.23 elongation and the force is 2.45 and the value of K average is 10.45. To find slope at graph spring constant 1, you must pick any coordinate you want. Just like me, I pick coordinate 0.2 and 0.9 for the first coordinate and 0.5 and 2.4 for the second coordinate, and just put the coordinate in equation m equal to y2 minus y1 divide x2 minus x1, and we can get 4.73. At the slope spring constant 2, just at the slope spring constant 1, we take any coordinate you want. Just like me, I take 0.09 and 0.98 for the first coordinate and 0.23 and 2.4 for the second coordinate, and we can get 10.14.
In conclusion, Hooke's law is a principle of physics that states that the force need to extend or compress a spring by some distance is proportional to that distance. Yang bermaksud, prinsip fizik yang menyatakan bahawa daya yang diperlukan untuk memanjat atau memampatkan spring pada jarak tertentu berkadar dengan jarak itu. Based on the procedure, calculation and graph, we can see spring 1 more elastic than spring 2. That's all for lab 1. Thank you.